Welcome to Cookie's Maths and Science Hub. Today we'll be exploring the concepts of empirical and molecular formula for chemical compounds. So, what's the difference between an empirical and a molecular formula? A molecular formula is a chemical formula of a molecular compound that shows the kinds and numbers of atoms present in the molecule of that compound. This is probably the type you're most familiar with, which shows all the different elements that are present within that compound. An empirical formula, on the other hand, is the formula that shows the elements in that compound in their lowest whole number ratio. If you look at the example on the left, we have C6H12O6 and CH2O as our empirical. All that is I've divided the top one by 6 because 6 goes into all of those numbers. In other words, the empirical is just a simplified formula of the molecular. You do have to be careful when differentiating them, however, as many elements can share, or compounds that is, can share the same empirical formula, but have very different functionalities and uses within society. We're going to take a look now at how we calculate these from some basic information. Below, I've outlined a series of steps that if you follow, you can solve any empirical or molecular formula question. Now to start with, we always need to find the empirical formula, as this is imperative in finding the molecular formula. So you can't really find the molecular formula without the empirical. So the first thing you need to do, sometimes in these questions, they might give you percentages. So all you need to do is convert any percentages given into masses. You then use the mass to find the moles of each element. Remembering, the number of moles of an element is equal to the mass over the molar mass. So you can get the molar mass off the periodic table and easily plug it into this equation. You then divide all of those results by the lowest moles present. So whatever smallest number you got, you divide them all by that. Then you round the numbers present to the closest whole numbers, because sometimes you might get a few decimals in this step. All this is then, assigning those numbers to each element that you've just found, is your empirical formula. Now, to get from here to your molecular formula, there's two easy steps. In a question like this, where you're asked to find the molecular formula, you'll be given the molar mass of that known molecular formula. So all you need to do is divide that molar mass you're given by the molar mass of the empirical formula found in steps 1 to 5. If you do this, you'll get a single number, and you round this to a whole number, and you simply multiply your empirical formula by the number given. That is, if you had a formula, say, of C2H6, and you got a 2 in this step here, you'd multiply the C2 by 2, giving C4, and the H6 by 2, giving H12. Now, these steps can obviously sound a little bit complicated when we're just looking at them like this. So let's look at an example now and break down each step as we go through it. Okay, let's look at what information our example provides. A compound of sulfur contains 2.46% hydrogen, 39.08% sulfur, and 58.46% oxygen. It is known to have a molecular mass of 164 grams per mole, and we're asked to find the molecular formula. So, our first step. Now, another additional step that we can add in here is writing it out as a table, as this can be quite helpful and process each step nice and easily for us. So we put our symbols down to help us indicate which element we're dealing with. So we've got hydrogen, sulfur, and oxygen. So our first step, using our steps that we discussed, is to convert any percentages into masses. So I'm just going to take that 2.46% and make it 2.46 grams, and do the same for sulfur and oxygen. Now, our next step is to divide those masses by the molar masses of each element. So for hydrogen, that's 1.008. For sulfur, it's 32.06. And for oxygen, it's 16. So divide each of those by those numbers. Remember, you can get those numbers off your periodic table. And that gives us 2.44, 1.22, and 3.66 for hydrogen, sulfur, and oxygen, respectively. Now our next step, so step 3 we're up to now, better not skip a step, is divide all by the lowest moles present. So in this case, if we look at which numbers we've got, we can see that 1.22 is our smallest number. So we're going to divide all three numbers by 1.22. This is dividing all by the lowest moles present. It's our step 3. So 2.44 divided by 1.22, 1.22 divided by itself, and 3.66 divided by 1.22. Now in this case, it's giving us whole numbers, but if these numbers were decimals, we just round numbers to the closest whole numbers, as it says in step 4. And as I said, this is your empirical formula. So the empirical formula of this compound is H2SO3. Now, in this question, we're actually asked to find the molecular formula. So the first thing we need to do for our next part of this equation, or this process, is to find the molar mass of our empirical formula. So we have 2, remembering that hydrogen's 1.008. I've just rounded to 1 for the simplicity of this question. So 2, because there's 2 hydrogens, plus 32.06, which is our sulfur, plus 16 times 3, because there's 3 oxygens, so we need to have 16 times 3. That gives us 82 grams per mole. We then divide the molar mass that we are given in the question of our compound, so 164 grams per mole, by the molar mass of our empirical formula we've deciphered. So 164 divided by 82 equals 2. We then multiply the formula by the number given. So 2 times H2SO3 gives us H4S2O6 in this example. So therefore, the molecular formula of this compound is H4S2O6. Thanks for watching. Hopefully now you can tell the difference between empirical and molecular formula, as well as how to calculate them. Be sure to leave a like on the video and comment for further topics you'd like to see explored. Please subscribe to the channel, and we hope to see you again soon for all your maths and science needs.